Hey guys, in follow-up with our topic, quadratic equation, we are going to be looking at nature of root of quadratic equation. Now, below is a quadratic formula where x is the root. Now, you understand with me that once you understand the topic variation, you find out that the value of x actually depends on whatever is in this root. Hence, the value of x, which is the root, depends on this factor b squared minus 4ac. It depends on this. All right. Now, just watch keenly and see the relationship and the properties. All right. Now, let's start with the first one. If b squared minus 4ac is actually equals to 0, which is the first possibility, then the conclusion is that the roots are real and equal. That is it. Now let's go to the second possibility. The second possibility is b squared minus 4ac is actually greater than 0. Now once you have this, it means that the roots are real and distinct, meaning they are different. They are real but different. Okay. Then let's go to the third possibility that we're going to be discussing, where b squared minus 4ac is actually less than 0. Now, once you have this, the conclusion is that the roots are imaginary. That is, they do not exist in a real plane. They are complex. We're not going to be discussing that now. So if you've grabbed what I've given, these three possibilities, can we now actually use it to solve a question? Let's solve a question. Let's solve an example to see what this is actually about. Okay, check out this question now. Now, this question says that we have an equation. We should find the values of p for which the roots are equal. So we are going to work with the first condition. And for the roots to be equal, we know that b squared minus 4ac must be equals to what? 0. Now the next thing is, how do I get my a, my b, and c? We are going to get it from the equation given to us. And the equation given to us is x squared minus 3x plus 1 is equals to p into x minus 3. What do? Simple. You see, this is given to us not arranged. So we have to arrange it so that it will look like a general format of a quadratic equation. But once you are given it arranged, there's no need for you to do this step. Okay? But for us, we have to do it. So we are going to have x squared minus 3x plus 1 is equals to px minus 3p. Then arranging further, I have x squared minus 3x plus 1 minus px plus 3p is equals to 0. Now, once I have this, then I'll rearrange and factorize. I have minus 3x minus px plus 1 plus 3p is equals to 0. So that I have x squared. I'll factorize minus x out so that I'm going to have p plus 3, all right, plus 1 plus 3p is equals to what? 0. So we are moving, all right? We can have it like this, no problem. Now, this looks like the general format of a quadratic equation, which is x squared plus bx plus c is equals to 0. If you look at it keenly, if you look at it very well, you find out that comparing the terms, my b is equals to minus into p plus 3. Okay? And look at my c. My c will be everything constant here. All right? So my c is equals to 1 plus 3p. Then, of course, a is going to be 1 because coefficient of x squared in both expression or both equations is 1. So we have it this way. Then remember, we have our form. We have the rule. Okay, b squared minus 4ac is equals to 0 for roots that are equal. So we'll come down. That is what we're going to be using. So we have b squared minus 4ac is equals to 0, which implies that b squared is equals to 4ac. So I'll substitute for b and a and c. And b now becomes minus into p plus 3 all squared is equals to 4. A is 1 and c is 1 plus 3p. I'm going to have, now once I square it, I'm going to have p plus 3 all squared. Now what seems to be the case is that once a negative is squared, it turns positive. That is why you see the negative is no longer there. So we have 4 into 1 plus 3p. Now this is expanding it. We are going to have p squared plus 6p plus 9 is equals to, expanding here, this 4 plus 12p. Now rearranging further, we have p squared plus 6p plus 9 minus 4 minus 12p is equals to 0, which will now be p squared. 6p minus 12p is minus 6p. Then 9 minus 4 is plus 5 is equals to 0. Now, this is a quadratic equation that we can actually solve easily through factorization. All right? Recall, we multiply these two extreme terms so that we are going to have 5p squared. Then we look for the factors of 5p squared that when we multiply, it gives minus 6p. Of course, it's very simple. So factors are, I can see minus 5p and p itself. All right. And is it p? No, minus p. All right. So we are done with that. We'll come back. We substitute for minus 6p so that we are going to have p squared minus 5p minus p, then plus 5 is equals to 0. And you know, the way we do it, you group it in twos so that you can factorize effectively. And this is what you are going to have. P is going to come out here so that you have p minus 5, of course. Then if you check, nothing is common between p and 5. So 1 is a universal factor. We can bring it out if you want. Yeah, there is no need to write it. But just for clarity's sake, let me just write it, all right? So I have p. Of course, you know this is going to be minus 5 instead of plus 5 again, okay? Is equals to 0. Factorizing further, we are going to have p minus 5 into p minus 1 is equals to 0. So we are edging closer to getting our answer. In this case, when p minus 5 is equals to 0, it implies that p is equals to 5. And when p minus 1 is equals to 0, it implies that p is equals to 1. Hence, finally, we can come to conclusion that our p is equals to 5 and our p is equals to 1. So these are the values of p that we have been asked in the question, all right, to find with that particular statement that the values or the values of the roots are equal. So thank you so much for watching. Do not forget to subscribe and keep watching, keep learning. Thank you so much.